Comments open, so you'll be able to comment. There we are. Welcome to everybody. We have comments open to this entire discussion, and you're welcome to post your comments as we go along. Let's introduce ourselves. I'm Tim Ottinger, also known as Agile Otter. You might have seen me on LinkedIn and various other social media, and maybe in conferences over the years. I'm still me. I'm still here. Industrial Logic, of course, is the company I'm in, and you'll notice a similar logo on the shirt of a Cecil Williams, Director of Training. Why don't you introduce yourself?
Good morning, afternoon. Yeah, I'm Cecil, and the Director of Training now for Industrial Logic. So I focus a lot on how we help clients improve, and excited to talk a little bit about what we think is the kind of what's gone on with CrowdStrike and their situation.
Yeah, I don't think anybody's been hiding under a rock and unfamiliar, but maybe do you want to give a quick lowdown, the Reader's Digest summary of the crisis?
Go ahead. I mean, I think you wrote about it, so I know you're a little more.
Okay, so let's do that. I'll post a link to my blog. We just mentioned it.
Yeah.
It's at the Industrial Logic blog site. There we go. And so you should be able to see that and take a read. So basically what happened is CrowdStrike is an important software security company. They've been providing security against breaches for, 13, 14 years. They've got a really good record, and it's a really tough business. But just a few weekends ago, they had a release that did not go well. They released a sensor description file, and it happened to trigger a long-standing code defect that had slipped through their net of tests. And as a result, it gave a memory error. But of course, since it runs in the kernel mode for Windows, the smart thing, Windows was right, by the way. I think Windows did the right thing, and it pains me to say that Windows was doing good things. It did the right thing. When the memory access violation occurred, it shut down. It went to a blue screen of death, and you had to reboot. And it actually, you could boot into a safe mode where you could delete the bad file once you knew what it was. So I think Windows did the right thing. But it did trigger a lot of outages, and a lot of people probably watching and listening now probably had some discomfort. It shut down ATMs. It shut down online point of sale systems. It shut down airlines. It shut down grocery stores. Banks. A lot of things went pretty pear-shaped there for a while until they released the fix. And sadly, the fix requires you to go physically to each machine, delete a file, and restart it. Which, of course, means if there are millions of machines down, many, many millions of hours of people driving to machines and shutting them down and manually making changes and restarting them. So this has taken a long time to recover. It's unfortunate.
Yeah. I think what I thought was interesting is when it first happened, my initial reaction, like a lot of people, I think, was, well, geez, how do these guys have that happen? They must be idiots, right? Like, gee, they don't even know, And then when you read into the details of what happened, I think it's pretty clear it was an edge case that they hadn't accounted for, and they introduced something new, and they didn't have quite good enough regression in place to make sure it was okay.
Yeah. Speaking of that, I think, Cecil, you have a timeline that you produced, or at least a bullet.
Yeah, it's actually the summary so CrowdStrike has published they had somebody externally do a root cause analysis, and they've published it on their website. This is the 6 findings that whoever they had do the analysis found. And what I thought was interesting and ties back to what you wrote about this whole incident, Tim, is that if you look at the first 5, they are all symptoms of lack of testing or lack of collaboration on verifying things. And then the sixth item is just that, we should have staged the rollout of this, and which in their case, that's one of the big problems, right? It was like how many billions of machines, I don't remember now, but it was a lot of machines that were impacted, and they just pushed it out to everybody at once. And they have testing environments, is my understanding, and they do some of that, but it didn't account for this change. And so one of their, for the remediation for number 6, as I understand it, is that they're going to, they can't, it doesn't appear that they have the ability to push to just certain machines or certain areas at a time, but they allow their customers, and they're trying to augment their system to give customers more control over when they would pull something in. So it's kind of like, if anybody here doesn't like to update their phone or their computer to the new operating systems when they come out, you want to wait until the .1 release or the .2 or whatever. That's, I think, what CrowdStrike's trying to give their customers more control over. But the first 5 things, these are all things that we advocate every day, which is, having proper tests. And we're not trying to advocate that CrowdStrike didn't. I'm sure, from what I've read, they do have a lot of the things in place to do testing and such, but they missed something.
Yeah.
And I think one of the things I really like that you covered in your article was the fact that we can try as hard as we want to think we get everything, but it's easy to, we're all human. We can miss things, and that's where working collaboratively and writing tests first and doing these things help to prevent that. So if you're not doing those things, then you're even more likely to have this kind of a situation,
I'd like to share a little sympathy because, they are in security, right?
Yeah.
Their job is to prevent breaches. And as you and I know, that's a heck of an arms race. Every time they come up with a better protection, somebody comes up with a better attack. And shutting down those vectors, you need special access.
Mm-hmm.
And, their software has to go through a fairly rigorous program to be certified to run at the kernel level for Microsoft. And they have that certification. And by the way, they got there with this bug in place. It's not like somebody knew absolutely that it was safe. It was the best anybody knew at the time. I will say that a similar problem had happened earlier. It did not create such a hubbub. It happened in their Linux product, and maybe they didn't have as many crucial worldwide systems running there, or maybe it was easier to remediate. But there have been other minor incidents. But again, this is security, right? And when you find out about an attack, a new vector, a new scan that you could set up, right? You probably want to get that out to your customers as quickly as possible. And I don't know if they thought this was a particularly egregious error, or this is, a really dangerous vector. Maybe they rushed to get it out the door. It doesn't seem like they did. It seems like it went through a normal release process. And the normal release process was not quite sufficient to catch kind of a problem. So I don't want to play the blame game. I think that those guys have been trying very hard to do a very good job for a very long time. But as you said, there are things that we do every day that would seem to have prevented this problem. And yes, this is armchair quarterbacking.
Right.
I know. But for instance, Perry, we work with a guy named Perry. He and I have been doing some work on the side, and it isn't even important work. It's some instruments for assessments and measuring things. Some of them for training purposes. And we had to read a file. Well, we didn't even write our own parser. We just used a JSON parser that came with the language we're working with. But we surrounded that with tests, right? And we fed it improperly built files. We gave it, bad JSON intentionally, strings that could not be JSONified in or out. We gave it directories that didn't exist, file names that weren't present, right? And we tried to test both proper action and error recovery. And that was on like a side project that wasn't even production code. You've written some file parsers in your time, I assume?
Oh yeah. I think everybody does at some point, right? You have to interact with data or doing something, certainly, right? And I think that's where part of this gets into, like, there's diminishing returns, like how much, and you touched on this, I think, in your article, like how much effort do you put into testing all the edge cases? Everybody generally we start with a happy path. We know kind of what we expect it to do. And now do we handle all the other things? And it's easy, we've done this for so long. I remember in the early days how much we would be like, I test it locally and it seems to work fine, so I submit it. And back even before pull request days, right? And people would it would get put into the code, and then you'd have somebody QA test it later and maybe find something, maybe not. But like, you kind of just, there wasn't a lot of emphasis on the testing is what I'm getting at, right? Like, you kind of do what you thought was good enough. You'd kind of, you're not going to test every edge case and all that kind of stuff. And again, we don't know the ins and outs of CrowdStrike. We weren't there, but you've got techniques now that we've learned over the years with extreme programming and such, that we can make sure we have really good test coverage. And the other thing that I hope, and I haven't really read this from any of the output from CrowdStrike, but I may have just missed it. But like, I know one of the things that we always like to profess is that, if you miss something, because we always do, right? We write the test we think of, as you said in the article, the manual testers will help, or people doing exploratory testing, whatever you want to look at that. But we miss something. The important thing is when you do, and somebody catches it, to go back and add automated tests to cover it, so you'll never have that problem again, right? Like, you've got to close that loop. You've got to come back and add that. And it sounds like that's some of the remediation that they're doing, is try to go in and make sure that they've got additional validation, additional assertions in their tests and things that are accounting for this. But again, I don't know the specifics, but I just know that's really important, because you don't ever think of everything.
So we'll take a little scenario about the way that we might work. So
yeah,
quite often we'll start off, talking about some feature we want. And one time, I'll give one of my stories. I joined with a company in Manhattan, and they wanted to build a new service. So we started talking about what it was going to do for some period of time. We said, okay, what's the most important thing it doesn't do right now? Well, it doesn't exist. Okay, well, what does it mean for it to exist? It needs to have a repo, it needs to have a test suite, it needs to have a pipeline, it needs to deploy somewhere. Okay, pop that in right away. Okay, now what's the most important thing it doesn't do? And they said, well, it doesn't process any messages at all. I'm like, okay, what's our simplest case? And they said, well, it should reject bad messages. So the first thing we wrote was that it rejects an invalid message. So the next question, what's the most important thing that it doesn't do? Well, it needs to process a message. Well, here's all the things it could do. What's the simplest case? Well, here's a simple case. So we put the simple case in. We had to have it validate that message so that it didn't reject it as a bad one and process it. And then we thought, well, what if the message is malformed?
Yeah.
So we tested that on the spot, right? So as we did this, we gradually increased the capability of the thing, always adding tests, always going through the pipeline.
Right.
The pipeline did stop us a few times because we had made a mistake and didn't realize. But also we had a PO working with the team. We had people who were testers. We had different developers, and we all worked together. So when one of us didn't realize what we should do, someone said, well, shouldn't we test for the other thing, right? So it wasn't one person under a lot of pressure in a shallow hurry trying to get this thing out the door to make it, hey, to get it to work at all, then we'll ship it. This, this process we typically follow involves testing, coding, retesting and retesting after every little change. It involves multiple people speaking up. By the way, that was a marketable feature in 4 days. They were able to put that service out.
Yeah.
So, even in side projects, but I think maybe one of the secrets is that we have people work with us. We don't work solo. Right?
I was thinking the same thing, that as I read through like the issues that they ran into where things didn't get caught, it feels to me like, I mean, even if they have a typical pull request process, of code review. Those are always hard to catch things like this. And I think where we tend to do either pairing or mobbing or ensemble programming, as it's more commonly now referred to, right? You're going to have multiple eyes on the code and what you're doing and viewpoints and different ideas. And it seems like people would be more likely to catch something. At least our experience is we definitely reduce the number of issues we have and increase the quality of the code that we're outputting right away, right up front, because we've done all that stuff together instead of doing stuff in solo. And if this was done by somebody and was handed to them, and if there was a pressure to get it out because, there's this new risk that's out there and we want to get it closed right away, you just don't know what those kind of situations. But if you're the person that's got that heat, it's easy to take shortcuts because you're trying to get it out. And that's where I think the group work really helps. The collaboration can make a big difference.
Yeah. By the way, I have an image. I'll share a little link. I don't know this company, Printables, and there's no relationship there, but they have this stamp that you can use for when you're doing code reviews. It's a rubber stamp with the initials of "looks good to me."
Yeah.
There you go. Just stamp it and let it go. When you're in a hurry and you don't test first and you don't have a process that goes quickly to market, we tend to find that what you do under pressure, when you should be at your most disciplined and careful and when it's most crucial, tend to be the wrong things, right? If I do a piece of work first and then I write tests for it and I really run short on time, am I really going to be thorough in my testing? Well, maybe not, right? And if we go to a code review and it's like, we need to get this code out the door, but you really should fix these security vulnerabilities and maybe bring it up to standard and don't use that API that's dying. Maybe we should quickly move this thing out the door. So when you get a chance, come back and fix that, and out it goes.
Yeah.
Right? If it's not the part of the normal way of working, if you don't always work in a way that's crisis safe, then in a crisis, you don't have anything to back you up. If they had those tests 5 years ago, this month would have been an entirely different month for them.
Very possibly. I think, we have a comment, actually. We should probably talk about Enrique's question here.
So here it is for everyone. It literally says, it's hard to believe they manually test things without closing loops with automated tests. So they are subject to the risk of regression into old bugs, aren't they? What do you think?
I think they have tests from the impression of the things I've read. I'm not sure that I don't think they were they're pretty sophisticated, like you said, what they're trying to do. So I think this was, again, to me, it seems more like an edge case, but the risk of regression is definitely there. And if that's why I was trying to refer to come back and close that so you don't ever have to worry about it again. That would be to me, an outcome out of this root cause analysis would be, we missed this. How do we make sure it doesn't happen again? And I get the impression they're doing that, but I don't know for sure, right? What all was done. But
there's a tough game with that, though, Cecil, right? Because on one hand, I'm hoping that the minute that they got this thing solved, at least, got a solution out to people, somebody was there writing that test. 21 elements and 25 and 2000, right? Feeding ridiculously sized files in to make sure that it's handled gracefully with exceptions or prevention. But they still have to go through the entire certification process at Microsoft, don't they? Do you know if once they got a certificate, can they continue to deploy, or do they have to?
I don't know how they interact with Microsoft and what their approval process is there, but a lot of companies have gates, right? A lot of companies have higher level. You can still be doing CI/CD and have gates. It's a matter of having those gates not get in the way. I've known a lot of larger corporations where they'll do continuous deployments, but not necessarily releases or delivery to a customer, right? So they're hiding things behind flags, feature toggles till things are ready, and they'd have a chance to catch something. This is kind of unique where they're trying to get it out and it's at such a root level of, at the level of the operating system it is. One of the things that struck me about this, I think, is I've seen this anyway, where I hope this wasn't a scenario where somebody thought, they're the person's been doing this for, forever and knows what they're doing, and they don't need to do a lot of the safety things that we would suggest doing. In fact, I've seen code years ago where somebody wrote a comment in it that this will never happen. And when you start getting arrogance involved and people thinking that their code is so well done, I interviewed somebody once that said they didn't write unit tests because they were working on pacemakers, and if the pacemakers didn't work, people died. So that was their criteria, I guess. And I was like, no, I think that should be even more. To your point about that's when you should the most be doing testing, right? So that's the crisis part of it. Like, it should just be standard all the time, and testing should just be a part of creating code. Like, if you get where you're a test after situation, and then what happens is you end up with not enough time. So what does everybody cut? They cut the testing because they didn't do it as just part of writing code. To us, it's not a separate task. You just do it as part of writing the code.
That's right.
And you don't have that as a secondary step later that you might skip. And again, I don't know that's the case here. But we're just trying to broaden it to more general, corporate software. You got to do this stuff because, everybody thinks this is not going to happen to them, but
but why not?
Why not, right?
You mentioned safeties, and one of the things I like to talk about is safety. So a safety is a mechanism that keeps a mistake from becoming a crisis. I think that is a very poignant definition. We've been using that for probably 7 years, maybe longer. But it is any mechanism that keeps a mistake from becoming a crisis. I think we've seen a lack of safety here. There could have been a technical safety for this, and there wasn't. By the way, there's talk about, of course, the directors, CEO George Kurtz. They say, well, he had a similar problem at McAfee years ago, and they've had similar problems. And so there's just a couple ideas to throw out there. One is, at his level, what would he have done to prevent that? Do you think he knew what the code looked like? Do you think that he has generated a shallow hurry kind of culture that where they rush things out? He's been in security a long time, and he's had problems before. You think that he would have been working on the culture of making sure that things are top notch. That may not be true, but I have to think, what could a CEO have done that would have made a difference in this scenario?
Mm-hmm.
Is there a cultural problem? I'm not in CrowdStrike. I don't know.
Right. I don't know.
Maybe someone can let us know if they have any inside information.
But I do think, to your point, we do see a lot of organizations where when they ask for help and we try to teach or introduce these techniques to them, a lot of times they have organizational constraints that don't allow them to fully adopt some of these things. And that gets frustrating to people when they know they can do better, but they've got hurdles in their way where, for example, like, if they've got to have approvals or things before they can release, that slows things down. If they don't have time, there's schedule pressure, so they don't have time to put in the effort to do the right things. Like, they may know what they should be doing, but they're being told, no, you don't have time to do that. Sorry. I mean, I've definitely had people share that, and it's unfortunate. And so you do have to get support from leadership to do things the right way. And, I think we find that, you have to, as you said earlier, you have to be able to always be doing the things all the time. And then what you'll find is then where the compromise comes in is usually around scope, right? That when you start getting pushed, well, okay, what can we live without? Because we're not going to give up, it's better not to give up testing, but to give up maybe a a lesser important feature to be able to make sure you can do the testing for the features that are important. Because if you have a bunch of stuff that's not tested, doesn't matter how much stuff you have, if it doesn't really work, it's not very good. But if you can do a smaller subset but do it really well, my experience, and I think yours would corroborate with that's going to turn out much better for people.
Yeah, I think if I were the director or the executive, I would be thinking very seriously I almost said post CrowdStrike. That's not right. It's the post outage.
Yes.
Period. Hopefully, CrowdStrike will come back stronger and more resilient. They'll have learned this lesson, have improved their processes, right?
Yep.
But the idea that people think that the only thing that they want from programmers is to make sure you turn around those tickets faster. People are in that kind of a culture, shallow hurry culture, ticket processing culture. They're going to have these kinds of problems. That's endemic to that way of working. If I were the director, if I were the executive, I would take this CrowdStrike outage as a wake-up call, and I would start maybe trying to turn my culture into one that values doing a great job and as fast as we can without compromising that, right? We want to move quickly, but there's a limit, right? Yeah, Jessica says, that feature can always come later. I think that's generally true for us. I think most of us are in an industry where if our feature came out 2 weeks later, it would not make a difference. Now, if I had a huge impending influx of attacks and breaches on all of my servers, I might feel a bit hurried too. But again, if the standard procedure is I can make a change now and make it live in 15 minutes, and we have all the safeties we need to do that well, why would I not?
And I don't know CrowdStrike's setup. I'm sure they have some internal ability to test and deploy to some sort of environment that simulates. I'm sure, but I think something related to this is the ability to experiment and learn and fail. Something teams need to have. That's something a leadership can support as well. And I think one of the things I've been really impressed with, whether you like them or not, whether you like the person in charge or not, SpaceX, the ability to, test and know that they expect their first few flights to fail, but they want to learn from that failure to make the next one better, is hugely important. And I think that's something everyone can learn from and see how they're applying exactly what we try to get people to do with software. Only they're doing it with very, very expensive rockets, and they're still doing it because in the long run, that's the only way they're going to be sure that what they're doing is safe.
And one of our employees left years and years ago. I worked with John for a while. He left to become a rocket scientist. He's doing this kind of work, building and testing rockets and writing software. By the way, we have a lot of Cecil. Most of you don't know. If you go read the blog, you'll read it's been in nuclear power.
Yeah.
We've done work in pharmaceuticals and in healthcare. We've done work in oil and gas exploration. We've done work in all these kinds of places where there's a lot on the line and things pretty much have to be right. And we've also done work in, lots of finance and then things that are just not even so crucial. But we find that these practices, testing with other people, testing while we write the code, building a pipeline of tests, these things have consistently sped us up. We're about out of time, but I don't want to miss.
This is a great question.
So you want to take this one?
Well, I think the one thing I mentioned would be to, if they've got automated test suite, make sure this is now included in that, right? Go back and cover, maybe look for other things that they didn't account for. I think they've already talked about, they're trying to improve on the deployment side, giving customers more control. But if this is a more traditional software thing, I think, releasing more frequently, smaller things, right? If I made a change yesterday and it goes bad when it gets released, I know what I just did that I need to undo. If I do a year's worth of work and I release that and something goes wrong, I got to figure out what in that year's worth of work was it. It's so much harder. The risk, we think, a lot of people think it's less risky to do bigger batches, but it's not. It's actually the opposite, because when you do something small, it's so easy to undo, and you know exactly the problem to go fix it.
They think that the releases are really risky, so they need to do fewer of them. What they don't realize is they're risky because they're so big, and doing fewer of them makes them bigger. It's a mindset. But I would say that probably right away, I don't know what their internal is, but if I was working with something that crucial, I would have people working in groups, because no one person knows enough. And we try to get around that, but most people know maybe 40% of their primary language and maybe 20% of its standard library. And they probably know quite a few things about, maybe performance or security, but 3 people know a lot more about those things than one person does.
Mm-hmm.
And then when it comes to testing, if you get, a professional tester involved, they're going to see things from the get-go that you just never considered or imagined. I would say that I would see working together and making the testing a standard part of development would probably be the 2 most powerful things that we could do to improve our situation, or if I were to say them.
I think those 2, and then I would add, integrating and shipping. So it's called continuous integration, not every once in a while integration, right? So people need to merge and be integrating their work at all times, because if they don't, it's so easy for somebody to get off on a branch for days or weeks at a time and not be pulling in everybody else's changes. And again, I don't know that this has anything to do with what CrowdStrike did, but it's just one of the things we typically see that can cause these kinds of things. If somebody goes off and does stuff on their own and merges it back, or does a PR, and then they have 2 people look at it, and those people really don't know enough about what was done, and it just, the code structure looks good, so they use your stamp, Tim, that you shared earlier, and they stamp it, and then and then all of a sudden you get this, you're on the front page of the New York Times, and that's not good for anyone.
That's the wrong way to make
the wrong way for it to go. And it's happened, and it can happen to anybody. And I think I can't emphasize enough that these practices have been around, like you said, for 20 plus years. That maybe the group work is something that's, I learned about it 11 years ago, I think 2013, when I heard about mob programming. So like, this stuff is all not brand new.
There's not a single new breakthrough necessary here.
There are plenty of books on it. There's plenty of websites, articles, training. We do training, other people do training on it. There's the conferences, people are doing talks on these things. There's no way to not learn about it and try to incorporate it. I think it's by far the best. Those would be the 3 things.
By the way, our blog has a lot of great articles on safeties. I'm going to pop a link there.
Yeah.
The another piece that goes with it, though, is whatever you ship is your product, right? They're shipping these data files, right? These channel files that, are the mechanism, right? Those are the things that they're shipping. Don't ship something you don't test, right? I mean, if I sent out a malformed help file for my online help and it caused my program to not start, dude, that's on me.
Yeah.
Somebody thought, oh, well, that's just a data file. It's not that important, right? But it's product. All the product you ship is product.
But I do want to come back and say, though, that I don't think you necessarily want to. There was obviously at some point there was some individual that did some change in some code, and I don't think you can blame that person alone. I think this is something where there are techniques and things that leadership can do to help individuals make sure they don't get into this situation, have this problem. And, this should be a learning opportunity, not a blame opportunity.
Right.
CrowdStrike or anybody else should be able to say, oh, you know what? Okay, let's help this so that this doesn't happen again. And what can we do even organizationally? Example, when I was a development manager many, many years ago, I had a gal, she was running a delete command on a database, and she thought she was in test and she was in prod.
Mm-hmm.
And I was like, okay, well, this happens, and we recovered because we had transactional logs from the day and we were able to reapply those. I said, they had to re-enter, a few hours of work, but not that much, because we had some things in place to help for something like this. And then, it's like, okay, how do we learn from this? What can we do to make sure that, we don't put you in this position? And, her initial response was, well, I'm certainly not going to make this mistake again, because I'm going to double check which environment I'm in. But, and there's probably other things we did. I don't remember specifically now, but I just remember that, these things happen. Everyone's human. People make mistakes. That's where we can help each other by working together and then having these other processes in place. So, looks like we had another comment from Joe.
I'll just answer that quickly. So it would be nice if CrowdStrike would write or present their findings and where did it all go wrong. They've actually produced a document. I think we linked it earlier, where they describe how it happened, and we presented a minor analysis, a short summary of it. They've been pretty forthcoming. Oops, sorry, I pushed the wrong one. Well, that's still true. So I think they've tried to be pretty good about saying what it looks like, but we don't really know their internal process. The easiest thing for them to do, if I were living there, I have a routine I've written to read the data files. So maybe my test for the data files, it'd be make sure I read them all before we ship them.
Mm-hmm.
And if we create a new one, the first thing we should do with the new one is read it using the routine we actually use, right? Just to link it to another executable that walks the directory tree and reads all the files. It's not new again, but
right.
But on the other hand, let me suggest this. Are there any companies out there that don't have the likelihood of something like this happening, where there isn't some file being read, that there isn't some dark corner of their code that may have had a 15-year-old bug or a 5-year-old bug? I mean, who really is immune from this? And without having a process that's just your normal daily way you work, of just testing everything as you go, maybe write tests before you write the code, maybe BDD, TDD, maybe work with a team who can come up with more tests. If you don't have that, then even if you have that, there's no 100% guarantee.
Right.
But when you don't have that, what are your odds? I think the odds are strongly against you. You're likely to have a problem like this already that you don't even know about.
And they may have even had tests where they were mocking or faking parts of this process, mm-hmm. and maybe they didn't account for this new type. And or how many times have we the mocks are only as good as what they're simulating. If you don't simulate something properly, sometimes you got to use the real thing to verify that your fakes and your mocks are right. And so there's so many things without being on the inside. And I do think the root cause analysis, at least the one I read, is very much centered around what was the problem that caused Windows to blue screen, and how did we fix that? Not systemically within the organization. How did we get to the point where there was a bad file in the first place? And I'm sure they've done that, and whether that's all been public or not, I don't know. I haven't seen it.
That's a good question, because when Joe asked that, it's like they didn't suggest how their process was left open to this.
Right.
I would suggest if you're working a company that's solo ticket processing, it's really likely that you'll have this problem. I don't want to go too long on that, but
I think we should probably try to wrap here.
I will say, so Cecil's director of training, so I'll say this instead of making him say it. We offer training and boot camps. Yeah, that is what he meant. Thanks, Joe. We do offer, the training on how to do these things, and you don't have to buy from us, but we do it really well.
Yeah.
We can help a team to incorporate teamwork, pairing, mobbing, swarming. There's a whole bunch of different ways that people can co-create code. We can show how that works. We've been doing this test-driven stuff and pairing since 96, 97. Some of us in 2005, 2006.
Mm-hmm.
There's nothing new in this. It's well understood, and you could learn it on your own, but I think you'd go much faster if you get some help.
Yeah.
And we would volunteer ourselves as people who could really help you turn around not only the practices, but the culture as well.
Yep. And I would just say, seek out, if you're interested in it, seek it out. There's lots of information. We're certainly a resource, but there are others. But try not to be the next CrowdStrike. That's the goal, right? Let's try to get safeties in place so that you feel like you can avoid these kinds of things. And
build the company that this wouldn't happen to.
Right.
And I think that's probably my final thought. Thank you all for attending.
Yep. Thank
Cecil,
you.
Final thoughts? Are we ready to go?
No, I think we're good.
All right. Well, thank you all for showing up, and
Yep.
we'll probably catch you on the next one around.
That's right. Have a great rest of your day.
Bye-bye.
Bye.